I believe this is from your book. I'm not sure which book this is. I think it's from your book. Anyway, so I'm going to just list this as an example problem. I've got a ball rolling horizontally off the edge of a platform. First of all, when it rolls off the edge of this platform, what is the shape of the path that it's going to take? Yeah, there you go. It's a nice parabola. Okay. So it's going to come down here and hit the ground at this point. They're also telling us that it lands 8.7 meters away from the edge of the platform. If I were to say what these two things were, right, what would I label them as? What quantities are they?
Initial velocity.
Yep. Initial velocity in which direction? Okay, so this is my V sub OX. And what is this? Displacement, yeah. In the X direction.
I would love to see some.
Does anybody know what the horizontal velocity would be right here? Halfway down. Yeah. Why?
Because the horizontal stays the same.
So how's it fast going? What about over here? Well, we don't know, right? I guess it could have lost some speed. But all throughout the flight, it's 7.6 horizontal. Do we know anything about the... Oh, first of all, we want to find out what this vertical displacement is. That's what we're asked to find. But do we know anything that's happening in the vertical realm? Let's see. Kathleen. Does it really?
Yeah.
Okay, Kathleen, give me just one thing. Do we know well, we don't know this. Do we know the time in the air, the vertical velocity at the beginning, or the acceleration after it leaves the table? She wants to phone a friend. Who are you going to phone? All right. She's going to phone Diego. Diego, what's happening? Do we know the acceleration in the y direction after it leaves the table, or the velocity in the y direction at the beginning? Yeah. Do we know how fast it's accelerating downwards after it leaves the table? Yeah. There we go. What if I threw it upwards? What would the acceleration then be after it leaves my hand? Okay. What if I threw it downwards after it leaves my hand? Still 9.8. Yeah, Lamar. Oh, yeah, where did you get 9.8 from? That's how fast gravity accelerates any object at or near the surface of the Earth. And when I say near the surface of the Earth, I'm talking about even up like on an airplane. Okay. So this is always going to be our vertical acceleration, unless they tell us that we're on the moon or we're on a different planet.
So when we jump up, like if I wanted to jump in the air, I have to go faster than 9.8 meters per second.
Yeah, well, when you...
Just because like the force of gravity is acting on us now, so like I would have to jump and break that force in this fast.
Exactly, you need a bigger upward force than that downward force of your weight.
So if you jump like up high, like harder than I would, you jump faster.
Your acceleration would be, say this is the positive direction, your acceleration would be positive right until your feet left the ground. So it would be different than 9.8 at that point. All right, what about our vertical, do we know how fast we're going originally in the vertical direction?
7.6.
Yeah, we do. Ashley, how fast are we going in the vertical direction after we leave this tabletop that's a horizontal tabletop? Zero. This, originally, as you're rolling across the table, right, you don't have any upward or downward velocity unless the table is at a slant. Right, so we know that originally this object has no velocity in the y direction. Well, guys, I left this as a 9.8. So what is that assuming? Rather than making it negative 9.8, yeah.
Downward is not.
Yeah. So,
Like, can you write up in the corner again, like which way it goes if it's positive?
okay, so you get to decide that. Do you guys want up to be positive in this case or down to be positive in this case?
Well, I think it would make more sense for us to do.
Okay. So we should define that, right? We should say that this direction is positive, and so therefore our acceleration is negative. But you could have just as easily said down is positive.
So you can just add that yourself.
Yes, you can. You just have to be consistent throughout your problem.
Okay, so if positive is going up, then I have another number that's positive.
Yeah, so say if this was launched at an upward angle, then your initial velocity in the y direction would have some positive component to it. Okay. Any other questions on the concept so far that we're talking about? All right.
How did you get wait?
Wait. Okay.
How did you come from me?
Again, this is always going to be true if we're dealing with a projectile because the acceleration due to gravity on Earth is 9.8 meters per second squared downwards. So always 9.8.
Wait, now for me.
Assuming it's Earth.
I'm sorry?
Now for me is always what?
That's always going to be our acceleration for anything falling or that's a projectile that will be in free fall. Yes.
Are they gonna give us the questions where they ask you like what will be the acceleration or whatever if it's on a different planet?
Well, yeah, they could ask you something like that, but then they would have to give you some of these other variables in order to be able to determine what that acceleration was.
Oh.
Okay. That's a good question because if you go to the moon's acceleration is about 1.6 meters per second squared. So you fall a lot at a slower rate. Okay. Woo! Now we want to know how tall that is, right? How far down it falls. I really don't have enough information yet, right? Because the only three equations we have are these three up here, v over squared plus 2a x. Okay. So if I'm going to use this and I want to find the verts, say these are y's. If I want to find this, that means I need to know everything else. And I don't know how fast it's going in the y direction right as it's striking the ground. So I can't use that. Can't use this for the same reason. I don't know this v. Can't use this one yet because I don't know what the time is. But do I have enough information where I could figure out what the time is?
Yeah.
Yes, I do. Okay, who said yeah? Okay, because yes, we do. And where do we find that? How do we find the time here? Yeah.
You can rearrange the equation for T.
We could, in fact, do that, yeah. Okay. Let me kind of point you to what you're going to be looking for in a lot of projectile motion problems is the time, finding the time. The x direction is the easiest one to find the time in this case. Look, I know that it goes 8.7 meters, and I know it's moving at this speed the whole time. Okay? So let's look at this in the x direction, right? So we know that x equals the original x position plus the velocity of the x direction times time plus 1/2 the acceleration in the x direction times the square of the time. But that's from our sheet. You guys don't have those sheets on the test. But what do we know about the acceleration in the x direction?
We don't know.
In the x direction, there is none. Yeah, t is time. There is no acceleration in the x direction. And so watch this. If I subtract x naught from both sides, what's x minus x naught?
The displacement of that.
That's displacement. Yeah, that's delta x. before you condemn yourself to failure, let's try to wrap our minds around this, okay? This relationship right here, derived from this thing that you have on your sheet, is the only thing you need to worry about in the x direction. This is the only relationship there. Right?
So you're basically just down to the side of the
Yeah, so check it out. If I want, now I can find t, right? Because I've got delta x, I've got v sub x. So t would then just be delta x divided by v sub x. Okay. Okay, so that's very messy. That's delta x over v sub x. Okay. And so let's just substitute and solve. Yes, sir.
So isn't there also an equation that's like delta x over t equals 20? So then you just write from that.
Oh, yeah, that's really good. It's not on your equation sheet, so that's why I didn't put it there. But the definition of velocity, right, or average velocity, is just delta x over time, right? And so it's the same thing up here. We're just rearranging it.
So if you plug it in, would it be 8.7 over 7.6?
Yes, ma'am.
Which is like 1.14
Thank you. 1.14 what?
seconds.
Seconds, right? It's important to use your units. You can see the meters are going to cross out. I'm just left with 1 over seconds, which is seconds. Okay. So now it's in the air for that long. Those of you that are feeling a little defeated, like, if I asked you how long did it take you to go 200 miles if you were traveling at 50 miles an hour, how long would you tell me? 4 hours, right? 50 miles every hour for 4 hours, that's 200. That's the same thing we just did here. How long does it take to go 8.7 meters when you're going 7.6 meters per
So are
second?
these going to be written out like word problems?
Yeah, then we learn the problem. Okay. But we weren't really asked how long it took to hit the ground, but we needed that to figure out what we were asked. How tall is that platform? Right, what is delta y? All right.
Did we find out?
So we've got enough information now, right?
Oh,
Since
okay.
we've got the time. Let's take our original equation here and change it to y.
Oh
Say
dear.
y equals y sub 0 plus VOY plus 1/2 AY t squared. All right, and you know what? Let's just subtract y naught from both sides.
This is t by the VOY, isn't it?
Oh, thank you so much. So that's delta y equals VOY times t plus 1/2 a in the y direction times t squared. Okay. We can simplify that even further, right? Because we had no original velocity in the y direction.
We could cross it out.
Right? We said up here, there is no velocity in the y direction. So that, yeah, that's all, that's gone. So let's solve for t. Multiply both sides by 2 and divide by a sub y, and then take the square root. Oh, wait a minute, we're not trying to solve for t, we're trying to solve for delta y. So we just leave it like that.
I think you
You
should
might
write
only
it
keep this too much.
Yeah, that's probably a good idea.
because this is basically like an
Wait a minute, I got negative 6.37 meters.
Maybe
Is that what you
should.
got?
I got positive.
You got positive.
That's because I used positive measurement.
Okay. So what would the negative mean in my case?
This is down.
but it fell down, right? We said positive was the up direction. So if you were to answer the question that they asked, how tall is the platform, and they gave you a multiple choice, would you pick positive 6.37 or negative 6.37 to answer that particular question? How tall is the platform? Yeah.
Positive 6.37.
Why?
Because it's, if you're measuring up, like, this, how tall is it? I don't know, I think of, like, tall as being from, like, 0 to however high it is.
Yeah.
So I'd say, like, 6.37 meters.
Yeah, it doesn't make
Not
sense to have a negative
enough. Yeah.
height,
Yeah.
right? Only negative displacement, yeah.
So maybe the final answer or whatever you get from your equation should be the absolute value.
Yeah, it could have been the absolute value of that for your height.
For this case, yeah.
Yeah.
Yeah, that's what I was gonna say. I always think of direction and time usually as being an absolute value. Or not, well, not distance, but I mean, like if you're looking at it like how tall something is, like the size of something is usually an absolute value.
So you're going to be asked to make those connections, right? Just applying this number and making sense out of what that means. Not just saying, oh, I got negative 6.37, so the answer must be negative 6.37. But understanding that that represents a drop in that much distance or that much height, therefore the height is positive 6.37. Okay, now I wanted to tie this into your lab, right?
Oh, dear.
Your lab was almost the same scenario, except you needed to predict what this distance would be. Most of you guys timed this and figured out the horizontal distance. All you had to do then was to measure this height, solve for the time, and multiply speed and time together to get that displacement. Okay. All right, we're going to do one now that has an initial velocity that's not in a horizontal route. Okay, it's got a vertical component to it. Before we do that, were there any questions on this?